Hello students, welcome back to the next session of Centroid. This is Professor Vidyasagar Mugi. Today I'll be taking up the next problem on Centroid. So in this session we'll be solving some more problems to have a better understanding of Centroid. So hope you liked the last session of the Centroid. I had given and I had discussed what are the steps to solve problems on Centroid. Hope you liked that. So in this part we'll be taking up one more problem on Centroid. So what you see in front of you is a irregular shaped lamina, so whose dimensions are given. So what is the first step to start with any problem in Centroid? So the first step is we have to fix up a reference axis such that the object falls in the first quadrant. Now the second figure what you see here is the same as the above one, so but it is shown with the reference axis. Now this figure I have given with what? I have given with the reference axis such that it is falling in the first quadrant. So the reference axis is with respect to the left hand bottom side of the object. After immediately when you fix up the reference axis, what is the next thing? We have to locate what are the possible known geometrical shapes that we can make out from this particular figure, so that we can divide them into the smaller areas. Now when I see this figure as 1, is it possible to locate the centroid? It is not possible, because I cannot arrive at any mathematical formulas. But I have derived some of the relations for some known geometrical shapes whose x bar, y bar have been already derived, and I know what are the values of x bar and y bar. So what I'll do is, for this given figure, what I'll do is I'll divide this given figure into the known geometrical shapes. Now how will I divide? So what are the possible known geometrical shapes that you can make out from this? You can make out from this. So one is, if I draw the straight line here, if I break this object, what is the shape that I am getting? I am getting a shape of right angle triangle. See here, I know this base, it is 3 meters from this tip. So if I divide this, I know what is its base, I know what is its height. It is 4.5. So I can calculate this. So I got one shape, it is right angle triangle. So if I draw one more line, so from this to this it is 6 mm. So if I draw one more line here, so what is the shape that I am getting? I am getting the shape of a rectangle, right? So the rectangle base is how much? 6 mm. What is the height? 4.5. Now what is the shape of this? This is the shape of semicircle. This is the shape of semicircle. Now this is semicircle. Now this 4.5 will be what? Height for this right angle triangle and rectangle. But the same 4.5 will be what? This will be the diameter of this semicircle, which is 4.5. Now I got the different geometrical shapes. I got 3 different shapes. So I'll mark them as 1, 2 and 3. This is the first step. This is the second step. I divided them into number of shapes. I got 3 possible geometrical shapes. Now to the next step. The next step is I need to subdivide those figures and locate their individual centroid of gravity. I should locate individual centroidal distance of those elements. Now what I'll do here is I'll subdivide them. So the purple line what you see, it indicates what? It indicates the reference axis. It indicates the reference axis. Right. Now where is this first shape? This semicircle is at what point? It is here. So semicircle is touching the reference axis. Semicircle is touching the reference axis. So its shape is like this, right? Then what about the rectangle? So from this reference axis, from here it is what? Semicircle. So leaving some distance, the rectangle part starts. Now to locate them with respect to their original position from the main figure. So this is the rectangular part, which is the second object. So this is the second object. Now where is the third object? Third object is somewhere here. So it is at what distance? So that is the distance of the rectangle and triangle. Right. Now what is the next step? Next step here is we have to locate their individual centroidal distance. Now the tricky part is with respect to the first figure. Tricky part is with respect to what? It is with respect to the first figure. Why first figure? You'll understand now. Now we have derived the x bar y bar value for semicircle. Now this semicircle, where should I cut such that area on left hand side and right hand side is same? Now if I cut it straight, will the area on left hand side and right hand side will be same? No, it is not. But if I cut it horizontal, whether the area on the top and bottom is same, means what? It is symmetrical about horizontal axis, but it is not symmetrical about vertical axis. So vertical axis is at what distance? Right, so let me show you a small part here. So when we derived the relation for semicircle, we had placed, I'll give some small explanatory notes here. So when we derived a semicircle derivation, so semicircle was placed like this, right? The semicircle was placed like this, and we calculated its distance from here, and we termed this as what? X bar. If you are not remember, you can go back and check the derivation video. So we marked this as X bar, and we had taken reference axis here like this, right? And after derivation we got to know that this value is 4r by 3 pi, 4r by 3 pi. But if you see from this problem, if you see this, look at this semicircle now. Semicircle, the circular part is this side and straight line is here. So from this to this center is what? 4r by 3 pi. So what is this full length? What is this full length? This full length is radius, and this full length is diameter, right? Agreed. So this is 4r by 3 pi. 4r by 3 pi is from what side? From this side to the center, right? Now this semicircle, what we have done in this particular question, it is reversed like this. This is reversed like this, and this part is touching what? The reference axis. But we have derived the relation for what? 4r by 3 pi is from which side? This side. So in this figure, where is 4r by 3 pi? Take this figure and keep it ulta. So where is 4r by 3 pi? 4r by 3 pi is here. 4r by 3 pi is here. But this is, I'll call this as G1. But from where do I require the x1 distance? So x1 distance is calculated from what axis? It is calculated from reference axis. But I know that this distance is 4r by 3 pi. But x1 is from where to where? x1 is from here to here. This is x1. This is x1. So what is the value of x1 now? So I know this complete thing. What is this distance? This is called as radius. How much is that value of r? So value of r is what? 2.25. So if this complete distance is 2.25, this is 2.25, then what will be x1? So x1 will be what? So this 2.25 is nothing but this is radius. So x1 distance will be what? R minus 4r by 3 pi. So that will be what? 2.25 minus 4 into 2.25 divided by 3 pi. So this will be your value of x1. So value of x1 will be, So you calculate this, so you'll get what is value of x1. So we'll calculate that later. Wait, we'll finish it off. So value of x1 is 4 into 2.25 divided by 3 pi. So it is 2.25 minus that. So you'll get this value as 1.29 mm. So we got what is x1. Similarly, what will be y1? So y1 will be what? So what is the total diameter of this semicircle? Total diameter of semicircle is 4.5. So this is symmetric about both the axes. So y1 will be what? 4.5 divided by 2. So this will be 2.25 mm. This is 2.25 mm. Okay, hope you understood this. Next, moving on to the center of the rectangle. Center of rectangle. What is x2 distance now? What will be the x2 distance? X2 distance is, you have to calculate that. Wait. So x2 distance I want, and what is y2 distance I need. Okay, we'll quickly finish off with y2 distance. So y2 distance is what? So what is the formula for calculating x bar and y bar for only rectangle? It is b by 2 and d by 2. So total height is what? 4.5. So y2 will be what? 4.5 divided by 2. So this will be 2.25 mm. 2.25 mm. What will be x2 distance? Now first calculate what is this distance. This distance is same as the radius of semicircle. So this distance is what? 2.25 mm. But I want x2 distance from what point to what point? So this is point G2, which is centroid of only rectangle. So I want from this centroidal distance to this reference axis. What is the value of x2? X2 value is, this is 2.25 plus, what is b of this? So what is this b? B is 6 mm. So x bar of rectangle is what? 6 by 2. So 2.25 plus 6 by 2. So we'll get 3 plus this 2.25. This is 5.25 mm. 5.25 mm. Similarly, for this rectangle, this right angle triangle, so this distance is y3 and this distance is x3. Now what is the distance from here to here, from the edge of the right angle triangle to the reference axis? So edge of right angle triangle to the reference axis means what? From this point to this point, it is what? 6 plus 2.25. This is 8.25. But I want from where to where? I want from center of this point is G3, from center of this to the reference axis. How much is that? So how will you calculate that? So for right angle triangle, I had told already that the CG will be, from this straight line, it is 1/3 of base, and from this side it is 2/3 of base. If you are taking from here, it is 2/3, from here it is 1/3. Similarly for height also, it becomes what? D by 3 and 2d by 3. Now what is value of x3 here? So x3 will be 8.25 plus, what is base of this? Base of this is 3. So we are taking from this side, which is this side. So that will be 1/3 of 3. So what we'll get? We'll get 9.25 mm. 8.25 plus 3 cancels 1. So x3 is 9.25. And what is y3? So y3, as I said, from this base, if you go to the CG, which is G3, so it is what? D by 3. So how much is the height? 4.5. So what will be D3 equal to? This will be 4.5 divided by 3. So this will be 1.5 mm. So we got what is value of x1 y1, x1 y1, x2 y2 and x3 y3. So once this is done, your work is over. Once you calculate this part, your 90% of the work is over. Next thing is you have to just put it in the tabular column and finish off. Okay, so after you split up the things, the next step is you have to write down those segments what you have divided into the known geometrical shapes. Now what are the components that we have divided them into? Semicircle, rectangle, triangle. Now you have to enter them in the tabular column. Now what is the area of the semicircle? So area of the semicircle is given by what? Pi r square by 2. So pi r square by 2. So solving that, so you'll get what? So pi into 2.25 square divided by 2, you'll get the area as 7.95 mm square. So writing a unit is very important, right? So area of rectangle is what? It is 6 into 4.5. 6 is the width and height is 4.5. So that will be 27. And triangle is half, base is 3 and height is 4.5. So this will be what? 6.75 mm square. Once you calculate the area, enter the values of x distance that you have done in the second step. Now what are the x1, y1 distance? I'll show you here. So x1 distance is 1.29 and 2.25 for semicircle. So firstly I'll only consider the x1 distances now. So x distance for semicircle with respect to reference axis is how much? 1.29. Then similarly x2 distance for rectangular element, it is 5.25. Then x3 distance is 9.25. X distance is with respect to what? Y axis, right? So that is the reason why I have written here as centroidal distance from y axis. So this y stands for the y reference axis. So that distance is what? X. So write the values of x1, x2 and x3. So semicircle is 1.29, rectangle is 5.25 and triangle is 9.25. So this is x distance. Similarly, go ahead and find out what is y distance. Now what is the y distance here? So y distance for semicircle is 2.25 and for rectangle it is also 2.25, for triangle it is 1.5. So write those values here. So for semicircle it is what? It is 2.25. For rectangle is also 2.25. Then for triangle it is 1.5. So this calculation is very important. Calculation of x distance and y distance. Once you calculate x distance and y distance, rest all things is mathematics. So area a into x, a into y. So summation a into x is this a1 into x1, a2 into x2. So first one is 7.95 into 1.29. Similarly, this is 7.95 into 2.25. We'll calculate that. How much is the value? So 7.95 into 1.29. So we'll get this as 10.25. And this one, 7.95 into 2.25 is 17.88. Similarly, this one, 27 into 5.25. And this is 27 is the area into 2.25. So 27 into 5.25 is 141.75. And this is 2.25 is 60.75. Similarly, area is 6.75 into 9.25. This is 6.75 into 9.25 is 62.43. Similarly, 6.75 into 1.5 is 6.75 into 1.5 is 10.125. Now what is the thing here? You have to add what is value of summation a into x and summation A into Y. Also add what is summation area. So summation area will be, add that 7.95 plus 27 plus 6.75. So area here is 41.7 mm square. Similarly, add this A into X. So this is 10.25 plus 141.75 plus 62.43. You will get A into X is 214.43. Similarly, 17.88 plus 60.75 plus 10.125. You are getting this as 88.75. So once you get these values, what is the next step? So next step is X bar is equal to what? Summation A into X divided by summation A. Similarly, what is formula for Y bar? It is summation A into Y divided by summation A. Now what is summation A into X? Summation A into X is this. It is 214.43 divided by summation A is what? 41.7. How much you will get? 2143.43 divided by 41.7. You will get this as 5.14 and unit is mm. Similarly, Y bar. Y bar is 88.75 divided by 41.7. So you will get value of Y bar as 88.75 divided by 41.7. You will get 2.13 mm. So this is the value of X bar and Y bar. So X bar will get 5.14 and Y bar is 2.13. Then the last step, once you get what is value of X bar and Y bar, is to represent. So from semicircle is 2.25 and this is 6. Means what? 2.25 plus means it will come somewhere here. It will come somewhere here. It will come somewhere here, and value of Y bar is 2.13 means what? Total is 4.5. So somewhere here. So from this you have to represent what is value of X bar and Y bar. Now from here it is what? It is represented as Y bar, which is 2.13 mm, and X bar is complete is X bar, which is 5.14 mm. This completes your one problem. So this is what is capital G. So this is what is capital G. Hope you follow this problem. So if you are really following this problem, make me know by hitting a like button for this video. Please do like the videos, guys, because we take so much of efforts. So please show us, encourage us by hitting a like button, so that it will motivate us to do much better videos and improve ourselves on day-to-day basis. Thank you very much. The next problem is what you can see in is a irregular shaped lamina whose dimensions are given. So in this problem what I have done is I have directly shown the reference axis there only itself. So what are the possible shapes that you can divide this figure into? So the next, you can see here I have divided that given lamina into 4 different parts. So first part is a right angle triangle, second part is rectangle, again third part is a right angle triangle, and fourth part is a rectangle. See here, what I have done is I have drawn a line here because I know this base and I will be knowing what is the height, 1.5 plus 1. So I can make out this. Similarly, this rectangle I know base is 2, then height is 1.5, 1.5 and 1. So I can make out this. This part I have drawn a horizontal line here which divides and make this into a right angle triangle, and this as a rectangle. So this height is 1.5 I know, and base is what? It is 4 meter given. Then this rectangle, when I divide, this will be 4 plus 1, 5 is the base, and height is 1 meter, which you can see here. Right. So this is how I have divided the figure or a lamina into 4 known geometrical shapes. After that, what is the next step? So next step is we'll subdivide the areas locating their own centroidal distances, that is small g1, g2, g3 and g4. Right, they have their own individual x1 distance, y1 distance, x2 distance and y2 distance. Similarly x3, y3, x4, y4. Now we'll start with calculating the x1 and y1 distance. So first, before we calculate x1 and y1 distance, what is the dimension here? So base of this right angle triangle is 2 meters and height is 2.5 meters. So as I said when I discussed lastly in the last problem, from this straight line to the center it was how much? 1/3. From this side it is how much? 2/3. Now reference axis is with respect to this tip. So what will be x1 distance? x1 distance will be 2/3 of, what is the base? Base is 2 meters. So this will be what? 1.33 meter. So x1 distance is 1.33 meter. Similarly, what will be y1 distance? y1 distance from base is d by 3 and from top it is 2d by 3. So from base it is d by 3 and what is the height? It is 2.5. So this will be what again? 1/3 of 2.5. So 1/3 of 2.5, you'll get the distance as, sorry, this is not 1.5, please make a correction. This is 5 meters. This is 5 meters. So 1/3 of 6 meters. Because why 6? Because from here to here it is 5 meters and this is 1 meter. So 1/3 of 6 is how much? 3 ones are 3 twos are 2 meters. So y1 distance is what? 2 meters. y1 distance is 2 meters. Similarly, now we'll go to the, what is the second element? Second element is this rectangle. What is the base? 2 meters and height is 1 meter plus 5 meter plus 1.5. 1 plus 5, 6 plus 1 point is 7.5. So what is x2 distance now? x2 distance from here to here, I know it is how much? From here to here it is 2 meters. How 2 meters? Because here this area is occupied by whom? The right angle triangle. So this is what? 2 meters. But I want from where? This reference axis to the center. So 2 plus, what is the formula to calculate centroid of this rectangle? It is b by 2. So b by 2 is how much? 2. So this will be, x2 distance will be what? 2 plus this 2 plus 2 by 2. So how much you will get? You will get 3 meters. Then total height is how much? 7.5. So this will be what? 7.5 divided by 2. This will be 3.75 meters. 3.75 meters. Similarly, now going to this one. Now this figure, if you look at this one, this I have calculated, this I have calculated. Remove this. Now I am only concentrating on third. Remove this. This is in the, this particular right angle triangle is nowhere in contact with what? Reference axis x or y. It is at some distance. Now what is that distance? So if you look from this reference axis, this right angle triangle is at what distance? It is at a distance of 1 meter. From this side it is at a distance of 4 meters. Now again, now we are calculating the centroid of this right angle triangle from this reference axis. So from straight line, what is the centroidal distance? It is 1/3. From this tip it is what? 2/3. Now this right angle triangle orientation here is what? Like this, ulta. So we have taken this as 2/3. But the same right angle triangle, it is reverse like this. So, and reference axis is here. So we are calculating with respect to reference axis. So this is 1/3. So what will be value of x3 now? Value of x3 is, from here to here, what is the distance? From here to here the distance is 4 meters. Why 4 meters? This distance or this space is occupied by this right angle triangle and this rectangle. So this is 2 meters, this is 2 meters. So this is 4 meters. So value of x3 will be 4 plus 1/3 of, what is the base of this? So base of this is 4 meters. Base of this is 4 meters. 1/3 of 4. So this will be 4 plus 1.33 is 5.33 meters. What will be y3? So from here to here I know that this is 1 meter. How 1 meter? I told you here this is 1 meter. So from base, what is the centroidal distance? So from base, that is from here to here, the centroidal distance is 1/3 of d. So what is the total height of this? This is 5 meters. So what will be y3 equal to? This will be 1 plus 5 by 3. That is 1/3 of 3. So this will be equal to what? This will be equal to 1 plus 1/3 of 5 by 3 is you get 2.66 meters. Now going on to this, what is x4 distance now? From here to here, how much is the distance? So from here to here it is 4 meters. So 4 plus, what is the width of this? This is 5 meters. So this will be 4 plus 5 by 2. So this will be 6.5 meters. Similarly, what is y4? Y4 is 1 meter is the depth. 1 meter, this is 1 meter depth. You can see here, this is 1 meter depth, 1 meter depth. So 1 meter is d by 2 is 1 by 2 is 0.5 meters. So we got what is value of x1, y1, x2, y2, x3, y3, x4, y4. Now what is the next step? Just write them in the tabular column. Now first rectangle, I have marked the markings here. If you see the markings, so these are the markings. These are the markings. These are the markings 1, 2, 3 and 4. So those marking, with respect to those marking, I will calculate x1 distance, x2 distance and x3, x4 I will write in the tabular column. So what is x1 distance? 1.33, x2 is 3 meters, x3 is 5.33, x4 is 6.5. So I will write those values here. So this is 1.33. So second rectangle is it is 3 meters. This triangle is 5.33 and this is 6.5. Similarly, I'll write y1, y2, y3 distance. So y1 distance is how much? 2 meters. y1 distance is 2 meters and y1 distance is 2, y2 is 3.75, y3 is 2.66, y4 is 0.5. So y1 distance is how much? y1 distance is 2 meters and y2 distance is 3.75 and this is 2.66 and this is 0.5. Now what is the area of triangle? So area of triangle is half, base is 2 meters and height is 2.5. So not 2.5, sorry, height is how much? 6 meters. Height is 6 meters, 6.0. So this will be half is cancel, so this will be 6. So rectangle is 7.5 into 2 is 15. Triangle is half, base is 4 and height is 5. So this will be 10 and this is 5 into 1 is 5. Now what is the next thing? You have to just multiply a into x, a into y. So 6 into 1.33 is 6 into 1.33 so this is 6 into 1.33, 6 into 1.33, similarly 6 into 2 and this is 15 into 3, this is 15 into 3.75 and this is 10 into 5.33, this is 10 into 2.66, this is 5 into 6.5 and this is 5 into 0.5. Now once we calculated this table, the next step is you have to calculate what is summation A into x, summation A into y. So summation A into x, summation A into y is, you have to summation A is 6 plus 15 plus 10 plus 5 is 36. So total area is 36. Then A into x is 6.6 into 1.3 is, this is 7.98. Then 15 into 3 is 45. 10 into 5.3 is 53.33. So this is 6 into 5, 6.5 into 5 is 32.5. So add all that, so we'll get the required a into x. So a into x is 138.81. Similar do it for this part. This is 12. So 6 into 2 is 12. 15 into 3.75 is 56.25. 10 into 2.6 is 26.6. This is 5 into 0.5 is 2.5. So adding all this, 12 plus 56.25 plus 26.6 plus 2.5, you will get 97.35. Now what will be value of x bar and y bar? So value of x bar and y bar will be, x bar is, a into x is how much? A into x is 138.81 divided by 36. So that will get 138.81 divided by 36. 36 will be, this will be 3.85. This will be 3.85, and similarly y bar you calculate. This is a into y, that is 97.35 divided by 36. You will get 2.7 mm, and this is 3.5 mm. So this completes your problem. So just mark the values of x bar and y bar. So this is 3.85 and this is 2.7. This is it. So these are the problems on Centroid for solid laminas. I hope you are following these problems. Any doubts, please feel free to ask. And the assignment for you people is this particular problem. You can have a look. So this particular part is called as the I section. So this top part is called as flange. This is called as top flange. This bottom part is called as bottom flange, and this part is called as the web. Note down this problem and solve it on your own, so you'll get any difficulties when you are solving. Thank you very much.